Hi everyone. So as Hannah just mentioned, I'm going to try to cram a lot of information that I hope is of value to you regarding artificial intelligence within SMEs. So just a little bit of an overview. I'm going to start with telling you about what we're going to talk about. What are the points that we're actually going to discuss? So we're going to do a little bit of an introduction on big data, just a little run through of what it is, what it means. Then we're going to dive right into some of the use cases that we can apply it to within the different industries. What use cases are what SMEs need, to be able to develop AI techniques. Then I'm going to let you know a little bit about some use cases that we've done within Telefonica. And to finish off, we're just going to speak a little bit about the latest trends within the world of AI. So to begin with, big data. Big data is one of those buzzwords. We've all heard it. We've all heard it for quite some time now. But what it actually refers to, it refers to a set of processes, technologies, different models that are all based on massive storage of data. And this massive storage of data, the processing of this data, and the transforming that data into actual valuable knowledge that is actionable within the business. This is the actual and most common definition that we can use to describe what big data is. But what are the characteristics actually that compose big data? So you might have heard on several occasions the V's of big data. Throughout time, these have increased. I've only got 5 here, but I'm sure you can even hear that there's 10 or even more so at this moment in time. So we're going to start just by talking about these main ones. And I'm going to start off with volume. So volume, it actually makes reference to the size of data. So data can be considered big data or not based on the volume that we have of it. So for instance, if we don't have enough volume of a specific kind of data set, we're not going to be able to feed that algorithm in a way where we're going to get the most precise outputs from it. So the more data we have, the more volume we have, the more accurate it will be. So the rapidly increasing volume of data due to cloud computing, IoT, mobile traffic, and all sorts of other different kinds of technology will provide us with all these different kinds of volumes. Then to follow, we've got the velocity. So the velocity makes reference to the speed at which the data is being accumulated. And there will be different processing times for that. So these processing times could go from streaming to batch, which is a little bit more traditional, and a mix of those two, making it a hybrid processing time. So depending on what we're wanting to do, we're going to require streaming velocities, we're going to require batch, or just a simple mix of those two. In terms of variety, we've got different types of data sources. We've got structured data, we've got semi-structured data, unstructured data, and these are all different coming from different kinds of sources. So for example, we're going to get into a little bit more detail on this actually in a bit. So you'll see some examples of it. What do we mean when we talk about veracity? So veracity is, obviously it's the quality of the data that we're looking at. Where is it coming from? Is it something that I want to be able to use? Is it something that will really give me the insights that I'm expecting? And obviously the value tied with this of the outputs that will be analyzed from all this volume, velocity, and variety of data that will be put into the mix. So big data is present in multiple sectors. And when we know the actual specifics within each of these sectors, so from telco, insurance, banking, industry, retail, public sector, you name the sector, we can develop big data use cases to be able to achieve milestones that we actually never thought possible using traditional BI. So very important to know the business challenge within each specific industry, and then that will that will be a step closer into actually being able to develop those analytical use cases. But since all sectors can benefit from implementing use cases, we're going to find them mostly along three axes of application. So we have the revenue increase, which is basically when a company is seeking to increase profits by discovering new insights, services, or products. And this could be something along the 360-degree customer insight, recommendation engines, personalization of products and services. So this is one of the main axes of application, but we've also have the operational efficiency, which is when we're actually seeking to optimize operations by making processes more efficient. So this is more and more something that we're seeing now with the Industry 4.0 that we'll also talk about a little bit later. And last but not least, we've got the risk reduction as an axis, which is when we're seeking to anticipate any irregularity that will slow down any process anomalies and fraud, and therefore will translate into a reduction of losses. And this is use cases such as digital security, advanced alert systems, customer churn prediction, fraud detection as well, which is something that we're worried a little bit more and more nowadays with everything being online. So this is something to take into account, highly important. These are some of the analytical models. So there are various types of analytical models when you're developing an analytical use case. But these typologies collect algorithms that meet certain needs and challenges. So depending on what we're trying to tackle, we're going to need to do a prediction, we're going to need to do a classification for that, we're going to need to do a segmentation, or whatever the case is. So these are the most important ones: prediction, segmentation, association, and optimization. We're going to take a deeper dive to see what examples of use cases we could tackle in the different industries with the use of AI. So for example, within telco, we've got the churn prediction and what is actually triggering that churn. So if we're trying to predict the likelihood of a customer leaving the company over a period of time and detect the main causes of that churn, we'll use advanced analytics techniques such as churn propensity for every customer of the company, using a predictive model in that case. Then to know what the churn triggers are, we're going to have to do a clustering of those customers. And the best way to actually see this, as you can see in the image, is to actually implement a dashboard that will show the customers with that highest propensity and what actually triggered it. So you'll see some examples here. And what do we need for that? Well, internal data. You always need your internal data, which is what I mentioned earlier, volumes of internal data. In specific types of data, so structured, non-structured, and we're gonna get into the details of how we actually process all of that later on. But some of that internal data could be the commercial exchanges, the social demographic informations, the claims and complaints. That will give you an idea of what is happening with the customer. So this is just one example of things that could be done within telco. Another example is advanced customer segmentation. So in trying to define different groups based on customer data, in order to improve upselling and cross-selling strategies, we can also use advanced analytics. So with this, we'll have to use a customer segmentation model in this case, apply clustering algorithms on monthly usage data, and also on the types of pages that have been visited. But not only that, but we'll also have to define marketing and advertising strategies based on the segmentation approaches. So in this case, we'll also be incorporating external data aside from the internal data that the company already has. So some external data could be socioeconomic information, registry information, especially the spending power by region. So these are two very common use cases within telco. But let's look at insurance. So for insurance, here it's the risk scoring and insurance premium recommendation. So what it is, it's trying to classify users in risk ranges according to their monthly default probability. And not only that, but with that information, design new plans and offer adapting price to the insurance premium so that we know that with that behavior, we can reduce the risk of default. So this could also be tackled through advanced analytics by doing the segmentation of customers based on the risk patterns that they have, and also by identifying the customers with the highest usage potential, and therefore knowing which are those limitations of interactions with the company. Another technique is doing the risk ranking, like you can see on the image, according to patterns, and that way allowing for a price recommendation to be put into place accordingly to those patterns. So this is going to be, you can see on the slide some of the internal and external data sources used in this case. Going on to the next sector, we've got banking, where we're trying to identify which those high value customers are for the bank. Some that may not be classified for them, maybe because they're having low activity, maybe because they don't have a lot of contracted services or products. So this is going to be something to look at. And also activating what marketing levers or commercial offers they need to be made to obtain the maximum return of those high value customers. So what we're going to do in this case is a customer segmentation, incorporating external sources and already those that are existing in the bank to have a really good idea of what those customers are like. Then the customer profiling by interpreting which are the most significant variables in that segmentation, differentiating high value customers and what their characteristics are, and then being able to create those customized campaigns for the high value customer segment. All of this using internal data such as corporate CRM, corporate ERPs, cash operations, along with other customer data of value to the bank, and external data such as demographic data, open data sources as well. These are very relevant, registry data, among others. So this is one of the banking use cases, but another one is the actual customer recovery. When we're trying to calculate the estimated recovery rate of those customers that have churned, it's going to be very useful to use information, so historical data in this case, based on past recoveries and what the common characteristics of those churns are, and the recoveries that made for them. And then also building a customer segmentation model according to the probability of recovery. So that way we have an idea more or less of what made them leave and what made them come back in the first place. So we're also going to be using internal and external data sources in this case. Within industry, we've got real-time stock management, which is actually something that we're also seeing a lot now with Industry 4.0. So here we're trying to implement a tracking and alert system for real-time management of the product stock in the supply chain. So what are we going to need here? We're actually going to need hardware here. We're going to need to sensorize the products. We're going to need to sensorize the goods, the systems used in the logistics chain, so from platforms to vehicles in the warehouses. So this is going to be the first step. Then the real-time alerts based on the events of the sensors that are going to be installed in the supply chain. So that's also going to give us a really good idea of what's happening. And then very important, which is what you're seeing on the screen, is the advanced visualization to collect all the different alerts and to be able to, in real time, facilitate that decision making. So this is going to be very useful to avoid all those downtimes. Predictive maintenance of equipment. This is also a very common use case right now within Industry 4.0, which looks to optimize the maintenance of equipment, of machinery, by being able to predict anomalies. So this is identifying the anomalies, first of all, based on unusual operating patterns, being able to categorize these anomalies using recursive partitioning models and validating based on actual real errors, and then using predictive models to determine the probability and time of that incidence. So all of that as well implemented into a dashboard is going to give us a really good idea to be able to make those decisions in real time. In terms of retail, this one specifically is about social listening. So it's actually understanding the sentiment around a specific brand, understanding the perception of a brand, who is speaking about it, what is being said about it. This allows us to extract actionable insights to be able to improve not only the user experience, but also to be able to design new products according to what is being said and what the demand and what demand is being seen. So these are just some clusters that you can see here of the analysis of the content of those conversations, and this is using one of the social listening tools. So we've obviously got internal and external information for this, and yeah, we've got internal, external information, and we've got as well. So the two main use cases. So the sentiment analysis. This is actually going to be using an indexing tool, and an exploratory analysis of those results, and also the posting trends and interpretation of them is going to be very easy to see with an image such as the one that you're seeing on the screen. Within public sector, so within public sector, this is one of our classic use cases. It's actually being able to predict crime in New York City. So obviously taking into account a lot of internal data, information from the police department, information from the city council, but also including weather, calendar of events, social media listening information. So what we just mentioned earlier in the prior use case, knowing what conversations are being held within what neighborhoods, what is happening in the city. So this is possible thanks to the use of machine learning algorithms based on identifying conflictive areas, conflictive neighborhoods, predicting what days, what hours have the highest crime, the recurrence of these crimes, and the geolocation of these crimes. And then as well, the propensity of establishments and prediction of conflict by day and event. So all of these are possible with advanced analytics techniques. But this is the interesting bit, right? So what does an SME need to actually develop AI? What do we have in the organization? What do we need? What are the pillars for it? And these are actually the 4 key pieces for adopting it. You need to have the right technology in place. So those technological enablers, the data, the analytical capabilities. So you need to have that skill set within the organization. And you also need to have a very clear strategy of how you want to tackle that, how you want to approach those challenges using AI. So we're going to run through what the technology enablers are, which are these basic tools and capabilities that are needed when operating in an SME. So these are just the main ones, basic digital services, and we're going to go a little bit deeper into all of these. Cloud computing, cybersecurity, Internet of Things, robotics and RPA, and big data. So for basic digital services, and I think that following the COVID-19 crisis, it's been possible to actually identify that there are some tools that are just very necessary within an organization. And these are broadband connectivity, virtual switchboard, digital workplaces, and online presence. So it is very important for us to nowadays have that really good broadband connectivity that actually takes into account the tools used and the service levels required, especially the service levels required. A virtual switchboard that enables a better management of the company's voice communications, those digital workplaces that are enabling the employees to work remote and actually providing them with tools such as CRM, ERP, enabling them with laptops, and last but not least, very important to have that online presence to strengthen that digital customer relationship. And this is very important now after what we've just been through. So these are the main technology enablers of basic digital services. Now, moving on to the next one, we've got cloud computing. Cloud computing, we all know that there's no such thing as a real cloud. It's just a computer somewhere. So cloud computer, essentially what it is, it's a model that allows the user to have on-demand access to a network of computers and servers within a shared pool of resources. So network, servers, storage, applications, and services, you name it. So you may have heard of the different modalities, such as platform as a service, service as a service, and then there's also on-premise. So I'm going to put in there a little mobility analogy that I like to use, so that we're clear on which is which. It's basically, in terms of mobility, if you had to think of an on-premise structure, it would be having your own car. Having your own car is something that it means that you're basically paying for it and you're operating it yourself. So you're taking care of everything. That would be the equivalent to an on-premise. In terms of a platform as a service infrastructure on the cloud, that would be like a car rental company. So you operate the car and you pay for the service, but the ownership and maintenance is not your responsibility. That is up to third parties. And then finally, a service as a platform would be a taxi. You just obtain the mobility, you obtain the service, but you don't have to drive it. You don't have to do anything else. You just pay for the service to obtain that mobility. So this would be a bit of an example of what a cloud service is. So with cloud, with more and more online presence comes this threat, comes cybersecurity. This is a very important technology enable. What can be some of the current challenges for SMEs today in terms of cybersecurity? It's protecting the company's digital assets, defining that specific protocol of security measures to be able to prevent and to be able to act upon that attack. So also being able to comply with those legal requirements and the current regulations, having the right staff in-house to be able to deal with such attacks, avoid unpredictable expenses derived from those cyber attacks, and raising the employee awareness of the risks involved from a cyber attack. So whichever the challenge, the reality is that with all these numbers of connected devices growing exponentially, the risks of a cyber attack grow in parallel. And a lot of SMEs don't have an active or an up-to-date cybersecurity strategy and are actually a gateway for hackers. And not only that, but a lot of SMEs don't even know, are not even aware that they've been cyber attacked. So this is a very important point that needs to be in place. So IoT, this is the next technology enabler. IoT is essentially internet-connected objects that are interconnected with each other. So IoT and big data actually are the perfect symbiosis. There's data generated and extracted in a very reciprocal way. So big data is the best mechanism to extract value from IoT. It provides business insights from a combination of sensor data that we're actually seeing more and more because we're putting these everywhere. So for example, one of the most widespread cases of IoT is actually within home automation. When you have that interaction between humans, between ourselves, and devices that are connected to the internet in our homes. So for example, lights, water, household appliances. We even have locks. You can open your house for somebody who's at your door, even if you're not at your door. And even enabling voice control through assistants, through Google Home, Alexa, Siri, asking them to do your groceries for you. There's all sorts of things happening within this world. And all of this is generating large amounts of data. So you can imagine that all these digital assets, all of these digital processes generate all this amount of data. And thanks to big data and artificial intelligence, we're actually able to understand what those mean and turn that into knowledge for the organizations. Now, one of the other technology enablers that we've got here are robotics and RPA. So as you can see from the slide, RPA is essentially allowing us to move from entirely human interaction with systems to combining automated processes. But the goals for robotics and RPA are the same, okay? But which is essentially the replication of that of that human action. But there is a slight difference that needs to be made between the two. And essentially robotics, excuse me, is used in multiple industries across the world. It's something that you'll see in warehouses with all these manufacturing, all these industrial robots that are deployed globally. And I mean, more examples even include the autonomous self-driving vehicles. These are also powered by robotics, by robots that also assist surgeons in healthcare. So this is the robotics side, right? And then RPA, on the other hand, what it is similar to the way that robots offload that mundane physical human function. RPA offloads mundane and time-consuming business processes, increasing the business impact. So some of these could be things, for example, as opening emails, extract structured data from documents, fill in forms, collect data from the web. So all of this, in addition to reducing costs, also leads to an improvement in the quality that can translate to increased revenue. For example, when we're seeing increased customer satisfaction due to eliminating human error and improved operating times, for that matter. Reduced ineffective visits by field technicians due to a more effective pre-validation. Reduced procurement times due to automation of manual tasks. Reduced penalties due to billing errors, and a lot of other use cases that this enables. So this is something that we're going to be seeing a lot more and more. It is not to replace, a lot of things are not replacing the humans, because there's still that need for human validation for many, many, many processes. So this is just something to help in specific processes to reduce those times, yeah? And last but not least, big data as a technology enabler. So what you have here on screen is actually the typical architecture of a big data environment. So from the data capture on the left to the actual data use on the right. And this is, in the middle actually is where all the magic happens. That's where all the data science happens. It's where the data managing, the processing, the analyzing tools, everything is put into place. So this is a bit of what a big data infrastructure looks like. So depending on what you're trying to achieve, you'll have your internal sources, your external sources, one application, one platform or another, one infrastructure or another, or even maybe hybrid ones, and you'll choose to use that data in one way or another. So this is just the first pillar of what a company needs to work with artificial intelligence. This is the technology bit, but we obviously also need the data. The data in an era that we live in that is actually generating millions of it per minute. This is an example of what actually happens in the internet in 1 minute. This is a lot of data. This is us being more connected than ever before. It is us demanding more than ever before. And we want it all in immediacy in all areas of our lives. If you think about it, we require constant communication with our family, with our friends, either by telephone, through social applications, through WhatsApp, Telegram, Facebook, Skype, whichever the app is. But we need to be informed 24/7 about things, have access to everything. When you want to look something up, you just pull out your phone, you Google it. We're used to actually being able to have the answers when we want them. We're used to listening to music when we want it, whichever time of day, whichever track. We no longer have to go to that record store to get that new record before we listen to a song or wait to hear it on the radio. And the same case comes when it comes to shopping. So we're able to buy anything from anywhere. I'm able to right now buy that something that will arrive later tonight at my home. This is something that is oops, I'm very sorry, part of our new world. Data is, as we've already heard it, it is called the oil of the 21st century. And it can be very overwhelming to have all of this data being generated, to know that you have access to all of it and to not know what to do with it. And this is where all these different types of data come in. So you've got the structured data. The structured data is that data that comes from financial data, sales data, warehouse data. It's all very structured. It's got a length, it's got a form, it's defined. This is basically stored in a data warehouse or a data market, very easy to understand, to read by everyone. It's just data. This is structured data, okay? Then we've got semi-structured data on the right, which is loosely organized into categories. It doesn't have a data model, but it has some structure. And this one, different to the structured data, cannot be stored in forms of rows and columns in databases. So this is going to require another kind of storage. And then some examples of this one actually are emails, zip files, okay, any information coming from web pages. And then last but not least, we've got the non-structured data. So the non-structured data is obviously the whole opposite of the structured data. This is all sorts of files. This is images, videos, satellite images, scientific data, social networks, mobile devices. This is anything that we're generating. Most of the stuff that we're actually generating today is non-structured. So this is definitely going to require a lot of skills and a lot of knowledge to be able to transform that into knowledge for the business. But we'll get into that shortly. So governance is very important. You'll see images here of a messy home and an organized closet, and then a library, the same thing. So you'll basically need to do the same thing with the data. So with all these organizations consuming and generating tremendous amounts of data, and all of this being housed in different having different regulations, having different standards, it's very important to have that data governance across, so that you can actually really work with the data and find those business instructs. So this is actually something that could be a little bit, you think, oh, we'll work about that later. But if you don't focus on actually working on data governance from the very beginning within a digital transformation of a company, you can end up very easily overwhelmed and with something that looks like a data swamp. This results in inability to gain insight from the information, reduced security, increased risk of exposure, and all of it obviously impacts that decision making, as well as obviously the ability to anticipate those problems or those opportunities that the business may have. So it's also very important to be able to have the technical side of the business to communicate with the business side of the business. That's why companies also opt for data governance, because it allows that transversal and standardized way of governance across to be able to be consumed bidirectionally, right? So this is a very important one to take into account. But aside from technology, aside from data, we really need to make sure that we've got the right analytical capabilities in place. So when we're trying to implement big data projects, we need to have a multidisciplinary team composed of a big data engineer, a big data architect, a big data business consultant, a data visualization specialist, and a data scientist. So as you can imagine, the big data business consultant is actually in charge of designing those analytical strategies, identifying those business needs that need to be solved through advanced analytical use cases. There's obviously a need of industry knowledge. There is no need to know any code, but it really helps to have knowledge of big data technology, on negotiation, communication skills, because this profile, this role is actually going to be speaking to other areas of the business to understand and to be able to put that into potential use cases for the company. Then moving on, we've got the data architect, which is actually in charge of developing, implementing, and testing the management of those big data platforms that I mentioned earlier. So needs to have knowledge in creating, integrating management systems, needs to be able to do data modeling, developing database architecture. So this is a very important role. And together with the data architect, we've got the data scientist. So the data scientist is the one in charge of compiling the data, processing the data, creating those algorithms and analysis of those specific analytical problems. And obviously this profile needs to have knowledge on different database systems, spreadsheets, communication, needs to know about visualization, about statistics, very important this one, statistics, mathematics, machine learning. But data scientist without the data engineer is gonna have, this is the thing, that they all need each other, right? So the data engineer is gonna be in charge of developing, building, testing, the maintenance as well of the big data processing environment. So there's skills required in extracting, transforming, and loading the data, spreadsheets, business intelligence tools, skills in data APIs as well. And then last but not least, the data visualization specialist, which is actually developing the most adequate visualization methods for us to be able to see in a very easy way what those outputs mean for us from a business perspective. How are those methods going to show us what we want to see, what we want to go to, right? So they're in charge of web architectures, API development, front and back end knowledge, commercial visualizations tools. This is a very, very useful thing to have dashboards to be able to visualize those outputs. And this is where this profile, this role comes in. So after having our technology in place, after having our data in place, after having our analytical capabilities, it is very important to have a very clear business strategy. We need to know where we're headed, what our objective is. We need to be able to identify the problem, analyze and understand it, and we need to be able to transfer that into an analytical use case. So this is, I'm going to show you here on this slide. I'm going to go step by step. On the left-hand side, we've got the three things that need to be really taken into account when you're trying to prioritize use cases, because within an organization that is finding that they have all these different use cases across different areas, it's important to know which ones need to be implemented first, to know which ones will give us that business impact, will be feasible in terms of technical requirements, and which ones will be the most scalable. So which ones will give us the most return across time as well. So this is, we can very easily wind up with 50 use cases, 30 use cases, depending on the company, depending on the needs at the specific time. But these are really needed to be taken into account. So within technical feasibility, we got to take into account the analytics and the visualization. So am I going to require complex algorithms? Can that use case be implemented without having to develop analytical models? Do I need to have a dashboard? Is it necessary to have an automated data ingestion? Does the model need to be later industrialized? So these are just some of the things that we're going to look at, we're going to ask ourselves when we're trying to prioritize. Another one is actually the data sources. So are these data sources available? Are they accessible? Is this integration of the data sources complex? Are the data sources that we have, are they structured? Is there a complex processing required for it? So this is also going to give us an idea of how the data is and what we're going to need to do to be able to work with those data sources. And then last but not least, within technical feasibility, we're going to have to look at technology and infrastructure. So we're going to have to see if real-time inputs are required, if real-time processing is required, if real-time visualization is required, and if so, if any licenses are required for that to work. So this is in terms of technical feasibility. So there's going to be a scoring regarding each of these different ones, right? Then in terms of business impact, so how many areas does it address? So does it address different business perspectives? Is it something, we need to keep in mind here the strategy. We need to keep in mind here the business feasibility, the customer impact, the nature of the typology, right? And then obviously the last but not least is the scalability. So if we're actually investing in doing something and implementing a use case, we'd love to be able to transfer that use case into maybe another store, maybe another point of sale, maybe another geography, right? Is that model scalable? And if so, what do we need to do to scale it, right? Can we just simply replicate it? Are there restrictions that concern any legal, human matters? So we need to take all of these things into account. And when we do, we wound up with something like we have on the right. So we're able to see which of those lists of use cases that we've got there listed on the left, which ones actually come out to be the most important, which ones have the most business impact and are most feasible from a technical point of view, and which one is the most scalable ones. And that will help you decide, that will help you communicate within the different stakeholders of the organization on which ones need to go first. So this obviously enables for us to create a roadmap, and we know where to start. We know when to implement each one, because some outputs of a specific use case can actually be more data for the next one, right? So they can feed into more sources of information. Okay, so those are the main things that we need to implement AI. So I'm going to just run through a little bit of success stories within SME that we've done within Telefónica. So this first one, Pedro Moreno and Hijos, this was an opportunity actually for digital transformation. So this is an insurance brokerage firm, and one of the managing partners, he basically realized that he was very far behind because he was still very closely linked to paper. So everything was paper. Invoices, tax returns, and as well the presence of customers, of clients in the premises. So with COVID as well, this made him take that leap forward, right? And he's reduced the paper usage by eliminating all those letters. He is now with the digital being implemented within the company, now he has greater knowledge of the customer, and we have helped him transform into that. We've helped him in the process of that transformation within Telefónica, and to this day, we continue to consolidate the changes within the process. So this is a not an analytical use case one, but it just shows the importance of digital transformation, of having to start somewhere. Because once the first step is getting rid of that paper, now is actually having that data, and now is being able to actually use that data to be more customer centric, to create more business value for himself along the line. So this is an example that is very, very aligned as well to this one, to aristocracy. So aristocracy is a jewelry sector. A lot of you may know it. And obviously the pandemic has also proved it right. This is one of our partners that we supported already with connectivity and communications, but new times mean new needs. So they were interested in omni-channel. So the customer being one, whether they were in the shop with us or online or after sales. So this is what we've helped them create. And with this, what they've done is they've minimized the impact with the use of, they've minimized the impact of the pandemic with the use of the technology, right? They build new ways of engaging with those customers. And today we're actually helping them towards the next step, and we're leading them towards that new solution called augmented reality. So this is another one very interesting on digitalizing processes within an organization. This one does have to do with analytics, advanced analytics. So this is Corin. This is an association of producers, farmers in Galicia. It has more than 4,700 members and associates. And this is essentially what they wanted to do is they wanted to reduce the costs, and they wanted to optimize the transport routes. So they had a fleet of 150 vehicles, and what they needed was a fleet management solution to improve the visibility of their distribution, the intralogistics, and that way it allowed them to allocate the costs to each member and to have those routes optimized. So this is a very, very good example of advanced analytics. So obviously some of the benefits were they were able to differentiate the kilometers driven by vehicles to avoid any derived costs, optimize that real-time routing. So, and obviously here we used internal and external data as well. This is for security companies, so alarm classification, and the aim of the project was to estimate in real time which ones were real and which ones weren't. So they wanted to improve the efficiency of the incident management process. So this one's also very interesting. Sorry, I'm conscious of time, so I'm going to try to run through these. This one was also, this is a shopping center, La Vaguada, and this was about helping them bring those retailers closer to the shoppers. So there was a lot of data as well involved from the actual retailers here. New trends in AI. Okay, this is, I've got some time left, so. Okay, so history of artificial intelligence. So we could very easily think that this is something from the last recent years, but it's actually something that started in the 1950s. And back then we were talking about statistical methods. Obviously with the incorporation of technology and having more and more volumes of data, we've elaborated and we've had incorporations of business intelligence. We've been able to go from artificial intelligence to machine learning to actually nowadays go into deep learning, which it makes a big difference. And now we're no longer talking about statistical methods, which is also artificial intelligence, but we're already past the phase of business intelligence, and we're at the stage of advanced analytics, which comprises all of these different ones. So today we do have the right amount of technology. We have the right amount, the right kind to be able to do what wasn't possible back then. But let's not say that they weren't aware what it could do. They just didn't have all the tools that we just talked about to be able to do what we're doing today with data. So these are just some of the disciplines of artificial intelligence: planning, optimization, so image recognition, machine vision, robotics, speech, so going from text to speech, speech to text, expert systems, machine learning, NLP. So these are just some of them. And I actually want to show you examples so that you can see a little bit what I'm talking about. So I'm going to go into the trends and technology very quickly here. So as we covered, we know what cloud is, and these are the three main large cloud service providers. They're commonly referred to as hyperscalers because they are capable of offering that large scale computing service with thousands of servers around the world. So, but when you're contracting cloud services, you've got different possibilities. You've got the private cloud and you've got the public cloud. So as you can see in the picture there, if you've got the private cloud, that cloud is only going to be yours, your company, right? And if you've got the public, you're going to be sharing that with different companies, even if you have your own measures, okay, your own security measures. And then obviously the hybrid cloud is just when you're mixing those two together. Yeah, there is sometimes the concepts of hybrid cloud and multi-cloud are used interchangeably, because this is another concept that you'll hear about. But basically, when a company combines clouds, which can be 2 or more public clouds, or 2 or more private clouds, or even a combination of both public and private, then we call that multi-cloud environment, right? So another trend in technology is the data lakehouse. So as we see here, these are storage systems. These are repositories for data. Data warehouse, I mentioned earlier, is where we have all that structured data stored, right? And this is a system that emerged in the 1980s. It doesn't support any semi-structured or unstructured data. So that's where data lake comes in, which actually emerged around 2011. And it allows us to work with larger volumes of data, different types of data. So we've got structured, semi-structured, unstructured data here. But it doesn't offer those guarantees of consistency and quality that we have from the data warehouse, because of all of that data structure, right? And then the data lakehouse actually emerges as that new innovative storage solution that combines the two. So it's suitable for working with large volumes of data, heterogeneous types of data, and it guarantees that consistency and that quality that the data lake doesn't. So then data mesh. You may have heard of this, you may not have heard of this. This is actually a very relatively new concept invented by a woman in 2019 called Zhamak Dehghani, and it is actually a domain-driven design. So instead of having the traditional that we have on the left here, where all the input sources go into the big data platform and then we have the data for use, what it's trying to do is it's trying to create a domain-oriented decentralization. So it's basically organizing the data by domains so that it has its own ownership, right? So this is basically a new way of working with data within an organization. And you'll hear more and more about it, but this is something very, very new. So I just wanted to quickly speak about it. Blockchain. Blockchain was also invented in the 90s, even if we think it's something from very recently. But it wasn't until 2008 that the first revolutionary case of blockchain was made, which was Bitcoin. So what does this technology do? This technology actually makes it possible to implement a decentralized trust figure without that human direct intervention. So this is capable of giving us that guarantee of information without the human, essentially, right? So we've got the data. So each block contains the same kind of structure. It's got the data, which could be anything from, so for example, for Bitcoin, it would be the information related to the money transfers, the sender, the receiver, the date, right? The hash, is the number that has been assigned here. So you see, for example, in block 3, 9L4Z1, that is something that it's unique, it's unrepeatable, and then each of these blocks are connected to the previous block. So this cannot be reverse engineered. This is the ultimate way of actually guaranteeing that the information contained in these so-called blocks is trusted information, right? So what do we do with this? For example, some of the examples that we can use is within digital assets, within contracts, and within property. We're going to take a more in-depth look in some examples I have for you in the next slides. Next trend is edge computing. So when we want to process data, the normal journey is actually device generates a piece of information and it travels through a network to a cloud, which is the image that you have here. So what is edge computing? It's basically, we're trying to do this. So because of the latency that is now required, what we're doing is we're trying to move that to the closest possible to the user, right? So we're trying to approximate to the very edge of the network because we require low latency data. So we need to move it closer to the user. Yeah, this is something that, for example, we'll see here in the connected car. So the connected car includes a series of cameras and sensors that are constantly capturing information in real time. And it could be connected to a smart city traffic, and it could be anticipating a traffic light. So that's going to require edge computing. It's going to be very close to the user, right? Thanks to edge computing, we can boost the power of game servers, reducing that delay, that lag that occurs every time that the user interacts with the game. And not only that, but also in the case of drones, which is another one of our new trends, new business actually. Edge computing actually allows the aggregation of that data from multiple drones using real time. So this is avoiding collision, facilitating logistics, aerial inspections. This is very, very important trend in technology, edge computing. This is a quantum computer. So this is our next trend in technology. It leverages developments from quantum mechanics to actually tackle those problems that supercomputers can't solve. So for example, we've got 2 combinations, 120 combinations, and then we've got 3,628,800 combinations. So when you're trying to hold all these combinations in the real world and process them sequentially, it takes a lot of time. And this is where quantum computing needs to come in. So we've got actually one of the providers, Amazon Web Services, has already made quantum computing available as a service. So this is these are some of the use cases actually that you can look to solve with it. Route optimization, serving more than 50 cities, investment firms trying to balance the risk of investment portfolios, and simulations of molecules in the pharma sector to better understand that drug-to-drug interaction. So these are very interesting use cases already made a reality with the use of quantum computing. Trends in data management, this is the bit around what is happening in the organization, in the management, right? So let's not forget what we've mentioned about data, how it's valuable, how it's a foundation, you know, how it must be complete, secure, etc. But what we really need to do here is make sure that that we're data literate, because if I want to be a data-driven organization, and only a small group within the company knows about data, then the chances are that we're not going to be knowing what to do with it. We're not going to be extracting the value from it, right? Even if you have that dedicated team, when you have that awareness, when you have that data democratization, which is what we're going to see here, and you give access, there's data literacy, you give the tools across the organization, putting into place obviously security and everything needed so that there's that balance, then everybody can have access to it, and it's so much easier to be able to extract insight from it. So data democratization is super important, data literacy being one of the branches of it. Ethics, this is something that you've probably heard quite a lot, because with new technology comes this delay in the legislation, right? And AI offers a lot of benefits to society, but there are a lot of drawbacks with automated decisions. There's always a chance of that error discriminating in some way. And not only that, but also with a lot of data coming in, I mentioned, how all those security threats were growing in parallel. So those are present, and those are a target for hackers. So the way models are built has to be done very carefully. The training data set needs to be carefully evaluated to avoid bias. And so this is something that all reputable companies should be considering, implementing the AI ethics, a code of data ethics on how data will be managed and analyzed in such a way to not put to disadvantage customers or even the wider societal communities that they deal with. So this is a very important key here. So machine learning and deep learning, we're going to go straight into some of the applications. Machine learning is based on learning algorithms. So there are different kinds, depending on the task, right? From linear models, decision trees, very complex. And deep learning is a particular case of neural network. So we're going to look at examples of this so you can very easily see. So this is a Van Gogh original. But when you feed it a lot of different data, a lot of different images of Van Gogh, it's actually capable of spitting out a copy using that deep learning technique and making it look like it was Van Gogh who made it. But it's actually, this is deep learning. This is not Van Gogh on the right. So, and this is called generative adversarial networks, this technique specifically. So we don't have time to play this, I don't think. But
you can go ahead and play it if you like.
Yeah, is that okay?
Yeah, go for it.
Okay, thanks, Hannah. This is called explainable AI.
So how can I help you? Hi, I'm calling to book a women's haircut for a client.
Yeah, we can.
I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have a 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
So that was an example of explainable AI, also called interpretable AI. And basically what it refers to is machine learning and deep learning methods that can explain decisions that would have been made by humans and that humans can understand. So that is pretty crazy. Digital twin. So this is another technological trend in analytics. It's basically literally a representation of something that exists in the physical world. So it's your digital twin, right? And this could be a physical object, process, a service. Sorry, I thought this was playing. Yeah, there we go. So you can see here, for example, this can be a digital replica of an object in the physical world, and what they do is, so they can actually see how this is going to perform. So by replicating it digitally, they can use real world data to create this simulation and predict how the product is going to perform. So this is a really cool example of that. So here's some, I'm not going to go over all of these, conscious of time, but I'm just going to mention some of the use cases that have been made possible with blockchain smart contracts specifically. So for example, with electronic voting systems, followmyvote.com, once the vote is completed, the smart contract automatically executes the relevant action and the result of the vote. So that's great way to avoid fraud. In the transport sector, together with IoT devices, it actually allows penalties to be imposed on the transport if the temperature of the cold storage drops below what's actually been agreed in the contract. So that's, for example, another example there. If we look at the one Spotify, so we got, for example, artists getting paid for the hits via smart contracts. It allows to eliminate those intermediates, and it's just a direct pay system between the artists through this automation that the smart contracts provides. We also have this with digital property, being able to verify art, being able to register information on clothing, on unique pieces. So there's all these different things enabled by blockchain. And then one of the last new business models that we've got here is autonomous vehicles. So we see how things have changed, right? From no autonomy to driver assistance, partial autonomy, where the vehicle combines the functionalities, but the driver needs to monitor at all times, right? To conditional autonomy, high autonomy, to a full autonomy, where the vehicle is actually capable of autonomous driving in all conditions, taking place by the robot, like we mentioned earlier. But this doesn't mean that the driver can't take control. The driver can still take control of the vehicle. And drones making it possible with blockchain, with fleet management solutions, with communications, with all these different types of technologies that we've spoken about. Drones actually are enable a wide range of use cases in multiple sectors that we're going to be seeing and hearing more and more of. These are just some of them. But drones is, yeah, definitely one of the new business models that we're going to hear about. And last but not least, the metaverse. So the metaverse, some may know it, some may not. You may have been in Mobile World Congress last week, where Telefónica actually announced the collaboration agreement with Meta to jointly explore the metaverse technology. So we're going to establish a hub in Madrid with startups to be able to look into this. And what is the metaverse, just in simple terms? It's the augmented reality space where everybody's going to own their own data. And it's not just another augmented reality space. It actually promises a world very close to reality. So it creates a new virtual world for developing social and professional activities. There's even, potential of being able to work within the metaverse. So metaverse has solutions for leisure, for retail, for education, all of the unimaginable. And this is definitely something that we'll be hearing a lot about. So that is it. I think that's the last of it. Yes. So sorry for
so
much of the time. Yeah, sorry for overrunning there.
No, it's all good. Thank you. It's a lot of really good information there. So, well, we've just had. There's a question. I'm not sure if you might like to answer it quite quickly, Marta. If you can see it in the Q&A box, or if not, I'll read it. I can read it out. So, someone's asked, how do you combine internal and external data? Names can be duplicated, addresses come in many different forms. What can be used to link unique IDs from different databases? What do you reckon to that? Can you, wait, I'm trying to find my cursor actually to reread it, because I can't. I can repeat it if you like. Oh, there we go. Hold on. I found the cursor. How do you combine internal and external data? Names can be duplicated. Okay, so this is where it's super important to know what kind of data you're actually trying to combine, what internal data it is, what external data it is, how
valid that data is, how structured it is. If it's not structured, you're going to need to put it into that different repository. So that there is a process of data cleansing. There is a process that needs to be put into place by all those different analytical capabilities, all those different roles within the organization that will allow and will put that into place. So it's not just going to be the data scientist having all this information thrown at him. It's going to be, there's going to be different steps along the way that will require us to be able to just mix these two different data sources together. It's possible, of course it is, and it's the key bit of advanced analytics, right? But it's actually being very clear about how to process each different type of data, how to process that structured data, that unstructured data, because 80% of what we have today is unstructured. So we need to have the right tools, those technological tools, those enablers to be able to do those things. Does that answer the question? I'm sorry. If there's any more questions, I'm be very happy to.
I think that answers it perfectly. Yeah, thank you. Well, what I'll say is that I'll be sharing Marta's email address with all of you who've joined us today. So if you do have any other questions about everything that's been covered, or more about kind of Telefonica services, you can ask Marta directly about those. But yeah, thank you again so much for sharing all that information with us. It was really, really, really insightful, very, very interesting.
Yeah, I hope so. It was a lot of information. I'm conscious of that. So I hope that
well, we'll have the recording, and I'll also share the recording with all of you who joined. So if you'd like to share it with any colleagues or contacts or anyone who you think it could be of interest to, please do feel free to do so.
Okay, fantastic. Thank you. Thank you very much. Thank you everyone for attending.
Thanks again, Marta, and everyone, and everyone enjoy the rest of your day. Thanks.
Thank you. Likewise. Bye-bye, Hannah.
Bye.
Everyone.